Let's write our first Python program by translating our networking event algorithm, where we calculated the cost of the event by summing the snack and beverage costs. Remember, the algorithm for calculating the cost of the event was get the snack cost, get the beverage cost, calculate the total cost as the snack cost plus the beverage cost. But before we start to code, let's first check out Python's rules for variables, calculations, and assignment statements.
Python's rules for naming variables follow the standard naming practices, allowing only upper and lower case letters, numbers, and underscores, and variable names should not start with a number. Python programmers have adopted the convention of snake case for variable names, in which variable names are typically in lowercase letters, with segments of the name separated by underscores for readability, like the variable name high-value. Since it is a convention, there is nothing in the Python language that enforces this way of naming variables, but it is the generally accepted way that variables are named in Python programs. Python uses the standard operators for addition, subtraction, multiplication, division, and exponentiation. The equal sign is used for assignment. In Python, a variable is created, that is, space is saved to hold its data, and the variable name is associated with that space the first time the variable is encountered during the execution of the program. This appearance must be in a statement that assigns it an initial value. So as we are writing our code, we can create a new variable whenever we need one.
Okay, let's get started writing and running a Python program from the algorithm to calculate party costs. As the default, program statements are executed in order. So we want to be sure that a variable has been assigned a value before we use its value in a statement. Let's start by creating the variables to hold the snack and beverage costs. First, we will create a variable named snack cost that will hold the cost of the snacks. We'll assume for this particular example that the cost of the snacks is $14.99, so we will assign 14.99 to snack cost. Next, let's create a variable named beverage cost that will hold the cost of the beverages. We'll assume, for this particular example, that the beverage cost is $10.55, so we will assign 10.55 to beverage cost. Finally, we will create the variable total cost to hold the calculation of the total event cost. We will assign the total cost the value of the variable snack cost plus the value of the variable beverage cost. And that's it. We have written our first Python program. Now let's run the program to see if it works. To demonstrate Python programming in these videos, we will be using Python Tutor. We will be using the site pythontutor.com for running and testing our programs. When you arrive at the Python Tutor website, you will see the following landing page, and you'll want to double-click on Python. If you scroll down, you will see the area where we can enter and test our Python programs. So let's go ahead and enter the code for our party calculation problem. First, we assign the variable snack cost the value $14.99. Next, we assign beverage cost the value $10.55. And finally, we calculate our result by setting the variable total cost equal to the sum of the value in snack cost plus the sum of the value in beverage cost. Now that our program is entered, let's run it. And we'll do it through the interface that allows us to visualize the execution. So simply click on the button Visualize Execution. In this area of the interface, it will show our code and also its current state of execution. A red arrow shows the next line to be executed, and since we haven't executed anything yet, it's currently pointing to the first statement. A green arrow will show the line that has just been executed, and on the right side, it will show the results of each statement as it's executed. So we'll start the execution of the first line by clicking Next. The first line that has been executed is shown with a green arrow, and on the right, we will see our symbol table. The result of the first line's execution is that it created the variable snack cost, because that's the first time it's seen the variable name, and assigned the value $14.99 to its memory location. Let's execute the next line. That's the first time Python has seen beverage cost, so it creates a new location in the symbol table for beverage cost and assigns the value $10.55 to it. Executing the last line, we will see that this is the first time it's encountered the variable total cost. So it creates a space for it in the symbol table and assigns to it the result of adding the value of snack cost, which is $14.99, to the value of beverage cost, which is $10.55, for a total of $25.54. This example shows how you can write and step-by-step test and visualize a Python program in Python Tutor, and also demonstrates that our program is working correctly.
Since making mistakes when programming is an expected part of the process, let's look at what some potential errors might look like. One of the most common errors is mistyping or misspelling a variable name. For example, let's suppose that when calculating the total cost, we typed snackcast instead of snack cost. So when the value of total cost would be calculated, Python would try to look up snackcast in the symbol table and would not find it. So the program crashes, that is, it stops executing and produces an error message. In this case, the message is name error. Name snackcast is not defined because Python's best guess is that the programmer forgot to create the variable snackcast since it was not in the symbol table. Let's correct snackcast back to snack cost, restoring the original code to calculate total cost. Now let's delete the line that defines snack cost. Running the program, we see it once again generates a name error message, this time indicating the snack cost was not defined. Even though they stemmed from two different programming mistakes, one a mistyping and the other missing the line that created the variable snack cost, from Python's point of view, these are the same type of error. In particular, the statement calculating total cost is using a variable that is not defined in the symbol table. This demonstration shows how the same error message can be caused by two types of programmer errors. So if you get an error message, look at the line that caused the error, as well as earlier statements in the program to find what might be the root cause of the error. And don't be discouraged by error messages. Even experienced programmers make common mistakes that result in error messages. The more you program and become used to getting error messages, the more comfortable you will become with finding and fixing them. A major drawback of our code is that we are only examining the variable values as they are stored in memory. However, the program does not produce any results that a person running our program can see displayed. In order for the results of a program to be seen by a person who is running it, the program must contain output statements. These statements direct the program to display information for the user of the program to see, for example, by displaying the results on the screen. So we'll examine output statements next.